Hi, uh, this video recording is basically about Monte Carlo simulation using Excel application. So now what we are doing here is we are doing the Monte Carlo simulation of two dice and getting the sum of the two dice, the random row of the two dice. So I can see in this table there's dice one and dice two, and at C At cell C4 and C5, we are using Excel function ran between 1 to 6 to generate numbers that is between 1 to 6 for the two dice. And for cell C6, we are getting the sum of these two cells. So you can see in this spreadsheet, the cells that are blue color are basically just labels. And the cell that is green color are basically result that we are interested in. And the cell that are orange in color are basically just cell that's used to do some calculation, especially for data tables generation. These two data tables here, and I shall demonstrate later why this orange cell will be important for the data table generation. And this cell E8, this orange cell is basically just a counter to trigger the data logic of this column E. So now we shall go step by step. So this is just a simple table with random generation and a sum. And the cell E4 is basically uh, to get the probability, the percentage of the sum that is greater or equal to 8. So this cell is basically count the value of cell C10 to C1009, and it's greater to 8, greater or equal to 8, then it will be counted and the total will be divided by 1000, which is the number of iteration, and from there we will get the probability. So now I shall show you how I use this. I shall show you how I use data table to generate this column B and C data table. So now I shall delete everything. Okay, so for column B is basically just a label, accounting label. It's between 1 to 1000 because we are doing 1000 iteration. So now in cell B10, I shall put 1 and I shall use Excel function fill series to fill up the rest of the cell. So we are interested in the series that is in column, and I want to fill it to 1 to 1000. You can see Excel automatic calculate for you 1000, which is in cell B1009. So moving up to complete this data table, we shall select these two value minus the labels. We are not interested in the label, we just need the value. And before we use the data table function, we are telling Excel data table that we are interested in the sum of the two dice. So from the first cell, we shall put equal to this C6, which is the sum. So now Excel know that, okay, this data table, you're interested in this sum of this sum value. So from here, we shall select all. We shall go to use data table function under data, what if analysis, data table. And here, since it's the one-dimensional data table, so we are only interested in the column because we are populating column-wise downwards. So the row shall be empty. And the column-wise, we shall tell Excel that we are referring this column input cell into a calculation cell, which is this orange cell here. So this orange cell is basically, after each iteration, this cell will include the calculation, the value, and this cell will be populated in all this cell below here. I shall demonstrate and I will explain to you later. I click OK, and you can see that it's populated downwards, and clicking on the rest of the cell, you can see that it is an array of the table and it's reference to cell B8. which is this calculation. So basically, the data table function will populate all this with the random sum of these two dice. You can see, which I'll navigate to below. So it's populated all the way to 1000 iteration. And this column E4 will get the probability by counting the cell that is greater than or equal to 8 divided by 1000. So this is how we get the probability. And what we are trying to show here is this probability later, when we press F4, will be locked into this column E. And this column E will get the average of all the probability and populate in cell F10. F10 is the average of cell E10 all the way to 2000. 2000 is because I want to cover the whole range, so it can be less, it can be more. So, but we won't be iterating 2000 times. So as you can see, now I shall demonstrate first what I'm meant by logging the value. So if I press F4, you can see that the value of cell E4 is logged into this column E. And it's not exactly the same value is because later in the VBA code, you will know that this population of this column E is actually re-triggering the recalculation of the probability. Therefore, this value that is logged here is actually a instantaneous value that is generated. So once it's generated, it's logged here, and once it's logged here, it will trigger another generation. Therefore, the value will be different, but it doesn't matter because it's still one of the value that is calculated previously. So this cell here will get the average here, and later you will see that as we iterate more, this value will get nearer and nearer to 41.67, which is the theoretically calculated probability of the sum of the two dice. And to do that, we use another data table, as you can see here. I shall demonstrate how I get this theoretically calculated probability. So I shall delete this value first. And the blue one are just labels. This is dice 2 and this is dice 1. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we are basically getting the sum. So this cell G3 is actually a calculation cell, and we are telling Excel that we are interested in the sum. That's why this is equal to C6, which is the sum. And to generate the data table, we need a calculation cell, which is this G3 cell. So now highlighting the whole table, use a Excel data table function, data, what if, a table. And now we are using a two-dimensional data table. So the row will be the dice 1, 1, 2, 3, 4, 5, 6, and the column will be dice 2, 1, 2, 3, 4, 5, 6. So we need to tell Excel that this is dice 1, this is dice 2, and we are interested in the sum, which is reflected by this calculation cell G3. So by clicking OK, the sum of the two dice will be populated in this green area here, as you can see. So now, this is the sum of the two dice matrix. So these yellow boxes are just a boundary to let us have a better visual that we are interested in values that are greater or equal to 8. So the total result will be 6 by 6, 36. And the result we are interested in is 15, which is calculated from here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability is just 15 divided by 36, which is 41.67. So this is the theoretically calculated probability of the sum of two dice if it is greater or equal to 8. So now what this Monte Carlo simulation is trying to show that by using multiple iteration, we should get a probability that's very close to the calculated probability. And now I shall show you the VBA code behind this triggering. And a lot of people will know that by pressing F9 is actually also recalculating the cell that has with the formula. But the problem with F9 is first it uh using the this I shall show you something first. Okay, I shall explain the VBA first, the back end first. So basically, we are using three environments: the module environment, the workbook environment, and the sheet environment. The module is basically just a public function that is used to add one value to cell E8, which is here. Why we need to add one value is because by adding one value, this cell change will trigger the logging of the probability. So from here, you can see that the code is, if the cell is empty, then give it 1. Else, the E8 value just increment by 1. So this is the module, the function, public function that we will call in this workbook here. So this workbook is basically a trigger, a workbook trigger that every time this workbook is open and activated, and you press F4, it will call this add one function to add 1 to this cell E8. So when this cell E8 has been added 1, it will trigger this worksheet change function, and we are setting the target to be E8, and every time E8 change, you will get the last row of this column, last empty row, plus 1, last row, plus 1, last empty row, and we shall populate the last empty cell with, the value of E4, this probability. So why we are not using the worksheet calculation trigger is because this calculation trigger, worksheet calculate trigger, is only applicable to cell without the formula. So cell that are with formula, it won't be causing the trigger. So that's why we are not using that as a trigger. We are using the worksheet change trigger, which is triggered by cell E8, the incremental of 1, to populate this E4 probability into this column E. And why we are not using F9, we're using F4 instead, is because if F9 will cause endless looping of this program, because if you press F9, it's actually causing this to recalculate, and when this recalculate and tabulate here, it will cause another loop to trigger. So it will be an endless loop. So by using this counter here as a trigger and using this worksheet change trigger in Visual Basic, it will not cause the endless looping. So basically, this is what this video is about, is using Monte Carlo simulation to generate the probability of two dice, the sum of probability of two dice. So now I shall generate more readings, and you can see that the probability will be maybe plus minus 0.25 away from the actual probability. So now I shall press F4 to trigger the logging and the averaging. And you can see the result is very near to 41.67, plus minus maybe 0.25. Right now it's exactly the same. See, it will be very near to as we do more and more. So now we are getting 43 iteration. So I hope this video uh, will explain to you guys who are interested in Monte Carlo simulation using Excel. And Monte Carlo simulation is a very powerful tool that is used in many industries, in finance, engineering, so on and so forth. to generate to using it a lot of iteration to generate some result that will be used for business, engineering, or whatever areas that you are in, whatever industry. So thank you guys for watching. So this is the end of my presentation. Thank you very much.